But hopefully this gives you an intuition why it's hard to build these sorts of challenging cases, because it's really difficult to find cases of light bulbs surrounded by planes. Finding out-of-context examples is actually really, it takes some effort. So accurately diagnosing the state of the art and how well things work, I think is a challenge that we will certainly need to address. Maybe I'll just sort of end with the final slide here. So the two take-home messages that I hope you walk away with is that, from my own personal point of view, I think one of the key enablers to enable AI to transition to robotics, to the physical world, will be building systems that are capable of understanding how things are structured physically and how things are changing and moving over time. And this interesting vision is inverse graphics. And then finally, the second sort of take-home message is that in order to really apply these incredible innovations in vision language and large language models to spatial understanding tasks, I think we can exploit multimodal prompting, where we give visual examples as well as text, but we'll also need to really kind of stress test and harden our benchmarking and evaluation practices. So with that, I'll end. Thank you.
Thanks, Deva. Any questions?
Thanks, Deva, for an amazing talk. So yeah, I have a question regarding multimodality and the things that you mentioned. So on this language to image encoder clip-like encoding, what do you think about fragility of prompting in general, and are there any other technique besides contrastive learning examples that you mentioned to robustify the final solution?
Yeah. So just to follow the question, so one was, how do we learn spaces that are multimodal? And another form of the question could be, everything is prompting is a very fragile endeavor. How do we solidify that? Maybe I'll dig into the second one. One interesting space that we've been looking at that other people have as well is almost like agentic prompting. So we almost have one LLM try to figure out the good prompts for another. We found that this actually works surprisingly well. And maybe I'll try to advocate for this with one more bit of color, is that from my experience, people tend to view prompting as sort of with derision, that that's just sort of prompt engineering or prompt hacking. And in my view, I think prompting is actually really, I think there is a science to it. I think about the way I interact with any good teacher, any good parent knows this, that the things that you say to your children, I might tell them, when my son is struggling with a math homework, I'll say, slow down, think through your steps, and try this again. And oftentimes the magic kind of prompt really changes, can get them to do the right sort of thing. So I feel like actually there really is this kind of legitimacy to how best we prompt and tell these systems what we want them to do. So I think it'd be great to sort of push on that in the future.
You mentioned that there are some difficulty discovering out of context content.
Yeah.
What other nuance limitations for AI that you have discovered personally that exists?
Yeah. So I skipped a couple of slides, but here's one that's really sort of surprising, is that if you're going to benchmark AI by asking yes and no questions or multiple choice questions, almost all the systems we saw have a bias for preferring yes over no, which is kind of amazing. So I guess because maybe we're just more of an affirmative society as well. Like most of the texts that we see, we tend to want to answer yes. What's also striking is that if you ask an A, B, or C, D multiple choice question, there's a bias. Does anyone want to guess what that is? It's not C, it's B. And so it's kind of amazing that these models have that. And it also seems interesting that evidently it's not that trivial to debias. If it was, I think they wouldn't suffer from this behavior. But it seems like somehow they're poorly calibrated. So my guess is that still is addressable sort of in the near term, but it was kind of remarkable to see.
Thank you very much. All right. I think we need to.
Just, sorry, just one
Okay,
question.
maybe last question.
Yeah, from myself.
Sure.
Yeah. Majid Khanji from Khalifa University. It's very interesting what you mentioned about the domain bias when you capture the data, and we actually face this in collecting data in the UAE, right? You need to keep retraining over different lighting conditions, different scenarios, right? I just want to hear your thoughts on the new regulations on privacy. One thing that we noticed, to publish a data set, you need to blur the faces, or you get consent from everyone in the city. So what's your thoughts, how to tackle this problem? Because it increases bias. Yes.
Yeah, that's a really good question. I don't know if I have any real particular insight on like how to address and navigate the privacy considerations. What I would have thought, and this is my own just personal, I'm not wearing an academic hat here, I would have thought people would be okay, I don't know, with sort of less privacy. Just given the sense of my kids want to post things and they seem to not, they want to kind of put their lives into the world. But clearly I think that intuition is wrong. And maybe correctly so. People are very concerned about the quality and secureness of the data. The reason why I find it such a hard problem to think about is I remember a certain project we were involved in, we were collecting camera data, and we had to we had to kind of make sure everyone was okay with this. And we have requirements such as, okay, if you're going to store data, blur out faces. This is exactly what you said. What we said is, okay, we're not even going to store any data, but we'll store, so we have cameras mounted in the university plaza. We said we will just store timestamps of, these were cameras mounted in a building, I should say, in different hallways. We will just store timestamps of when motion was detected. And so we're not even storing any faces, and so we were allowed to do this without privacy sort of privacy issues. But I'm almost positive that just with timestamp labels for cameras mounted in a building, I could tell when people came to work, I could tell when they went to the bathroom. I can kind of derive or infer all of that from the data. So one thing I always struggle with these privacy concerns is that there's all this hidden knowledge that exists there that you can pull out, and so maybe privacy is a bit more this psychological. Like I feel better if my face pixels aren't stored somewhere, but probably if someone really wanted to, they could really kind of find things about me by piecing together clues in different data sources. So yeah, I don't know if I really answered your question, but I find privacy to be such a difficult thing to address.
All right. So let's thank Deva again.